Question 1 here, a bacterial colony with an initial population of 300 doubles every day. Well, all of these questions can be modelled around the formula y equals ab to the power x, where b is the rate and the a value is the initial amount. This is fairly standard. So if we look at this question, we know that the initial amount, the starting weight, is 300, and it doubles every day. So that means that the b is 2. So this formula is quite easy. It's y equals 300 is the initial amount, a is 2, b is 2, and 2 to the power x. So we're looking for an equation. Question 2 is a bit strange for a review question, but it tells you to pick a model. Let's pick y equals 2 to the x and sketch some points out. So let's go with 0, 1, 2, 3, 4, and 5. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed 8, 16, and 32. Then b talks about writing the first and second differences. Well, 2 minus 1 is 1, 4 minus 2 is 2, 8 minus 4 is 4, 8 and 16. If you look at these second differences here, all the numbers multiply by 2 again. Then it asks to look at the second differences. So 2 minus 1 is 1, 4 minus 2 is 2, 8 minus 4 is 4, and so on, 8. And again, even in the second differences, the numbers multiply by 2. So that is something that's consistent with an exponential function. Part D says write an equation to model your growing. Well, we've done that initially. This is the model here. How many objects would you need to build the 10th term? I'm not sure what that question means, actually, to be honest with it, but anyway. Question 3. Anything raised to the power 0, any non-negative number. So 6 to the 0 is 1, 3 to the 0 is 1, that's always the case, that's A. And then B says prove it algebraically. Well, we know that 10 squared divided by itself must equal 1. If we look at the way the rule of exponents works, a to the m over a to the n is a to the m minus n, therefore 10 squared over 10 squared, which we know is 1, is 10 to the 2 minus 2. And 2 minus 2 is 0, which then equals 1. Question 4, radioactive substance with an initial mass of 250, so that's your A value. So we know that y equals 250. And then B, it's got a half-life. Well, that means the power we're multiplying by each time is 1/2. So 1/2 to the x. Basically it's saying is that t is years and weight is the weight after so many years. After the initial weight is 250, after 1 year, its half-life is 1 year, after 1 year 250 it will be 125 grams. After 2 years, another year goes by, it goes half again, 62.5. Another year goes by and it's 31.25, and every year it loses half its weight. Write an equation to relate, this is A here, write an equation for the formula, there it is. What will the mass be after 10 years? Well, you've got to substitute 10 in, so y equals 250 times 1/2 to the power 10. And you work that out on your calculator. How long will it take for the sample to decay to 20% of its initial mass? Well, if it starts at 250, 20% of that is 1/5. So we want to find out what time when it's 250. And you need a calculator for that. Question 6, evaluate each expression. Okay, let's just do a couple here. We know that if we take A here, 6 to the -1, for instance, would be 1/6. 3 to the -2 would be 1/3 squared. These are all equivalents to AB. C Not sure what C says. It says for an equivalent question would be something like this. So we can't combine them, so 1 over 4 squared plus 1 over 2, that's a quarter plus a half. Common denominator is 4. So 1 plus 2 quarters, because 1/2 is 2 quarters, so 3 quarters. So try question 6 on your own. Interesting F, let's have a look at that. If we did 2/3 to the -3, well, we flip the fraction, so it's 3 over 2, and to the +3. On the top here, 3 cubed is 27. On the bottom, 2 cubed is 8. Question 7. Again, we're just looking at what we do with these powers. If you look at A, let's have a look. W the -3 times W the -1 times W to the 0. Well, we know W to the 0 is 1. If we add the powers here, -3 plus -1 is -4. If we look at something like D, W -3, B 2 over W -2 times B -1. So all the negative signs will change sign, so this one will come down and that one will go up. That one's up, that one's down, and this one will go up as well. So we get B squared on top, that stays where it is. The B -1 goes up as B1. On the bottom we get W3, and of course the W2 went up as well. So on top we get B squared times B is B cubed, and W cubed on the bottom underneath W squared is going to be W on its own. So the final answer is B cubed over W. Question 8, do some evaluations here. Of course we know that A is easy. If we have something like the cube root of 27, that's 3. If we have a look at this one here, D, and we say something like 1 over 32 to the power 1/5. So it's the 5th root of 1 over 32. We can do it in tops and bottoms. The 5th root of 1 is 1, and the 5th root of 32 is 2. So the answer is 1/2. Look at H down the bottom there. If we have 2 over 3 to the -2, we know we flip it. 3 over 2 to the +2. On the top, 3 squared is 9. On the bottom, 2 squared is 4. And just take a look at I. Let's do this one for you. -27 over 125 to the power -2/3. Okay, we'll do the 3 first. 3 is the cubed root. Well, the cubed root of -27 is -3, and the cubed root of 125 is 5. And then we've got left the -2. The negative sign will flip it upside down, so it's 5 over 3. And to the +2, top is 5 squared, 25, and the bottom is 9, 3 squared. Question 11 here, determine the equation. We know goes through these points here. We've got 0, 10. So we got points 0, 10, one at the bottom, 140, and 2, 160. Is it exponential? Yes, it's multiplying by, these y values are multiplying by 4. So we look at the function a b to the power x. Well, the a value is going to be the initial point when x is 0, so that's 10. Y equals 10. B is what we're powering up each time, so 4 to the power x. Question 12. Y equals 2 to the x minus 3 plus 4. Domain is easy, all real numbers. Range always revolves around this last number, and the graph is going to look something like this. with 4 being the upward shift, and that value there is y equals 4, which will be answer C, I think. So the range is going to be y greater than 4. Not greater than or equal to, greater than. And the equation of the asymptote we've already stated is y equals 4. And you can always find the asymptote by this bit at the end of the function here. Here we see the answers for 13. A is a vertical stretch, factor 2. B is a horizontal compression, factor 1/2. And C is a reflection of the x and the y-axis. D is a complicated. It's a -10 is 10 units to the right. The 5 is a horizontal compression, and negative sign in front is a reflection of the y-axis. Going to do question 8 here. Got to find the graph. Well, we might have done this before. If we look at the graph A, it's a parabola. Well, there's only one parabola there, y equals x squared. That should be easy. B is a straight line, linear. Y equals 2x. Again, should be easy. 2 to the x. If we plot some points, if x is 1, for instance, then y would be 2. And that's going to be that point there. So it's easy to see which one this one must be as well. And these graphs are all where the a value is greater than 1, and these values are all graphs of a less than 1. Question 9. We've got to find the domain and range. Popular question. So y equals 2 to the x minus 5 plus 3. Well, the domain is going to be all real numbers. B, the range, relates to the 3 at the end. This graph has been shifted up 3, so range is y greater than 3. And then C, the asymptote, is going to be y equals 3. So quite easy, 1, 2, 3, and a fairly common question to ask on a test or a quiz. Question 10 here talks about the transformation. This one is going to be a vertical compression, factor 1/3. This one's going to be a horizontal compression, factor 1/4. This one's going to be a reflection of the x and y axis, and this one here, we talked about it before, the -6 means 6 to the right, the 3 means horizontal compression, factor 1/3, and the negative sign, a reflection in the y axis.